million Wisconsinites. About 10% of the state's residents live in what's called a food desert, with little or no access to fresh
New at 10, addressing the problem of a food desert in Englewood.
10% of Indianapolis residents live in an area like this, known as a food desert, with access to fresh food more than a mile away.
3.5 million Americans who live in a neighborhood which the USDA calls a food desert. That means they have limited access to healthy, fresh,
with a lack of access to healthy, affordable food. One of those communities sits along Statesville Avenue.
The survey shows that millions of Americans are dealing with this, and we didn't have to go too far
about cities. Some of the state's most rural counties also have little or no access to
this
local
designation
grocery
to
stores.
identify places that have limited access to
for some of the 30 million Americans, including more than 100,000 North Texans who don't have access to fresh food. It's called
With amber waves of grain and stretches of fruited plains, the United States is often referred to as the breadbasket of the world. In 2023 alone, U.S. agriculture produced nearly 667 million tons of crops. That's enough to feed around 119 million households. It appears that our rich farmlands should more than sustain our people, in both hunger and in health. But is that the case? Traditional agriculture has supported mankind for thousands of years, and developments in science and technology have enabled farmers to produce more and more, but there are many challenges facing today's food producers, from unpredictable weather and irrigation obstacles to soil degradation and pollution. Our evolving landscape presents countless obstacles. Populations continue to expand with more mouths to feed, while at the same time pushing farms further and further from local access. This contributes to one of our biggest crises, the health and food accessibility of many living in what are called food deserts. According to the USDA, approximately 23.5 million Americans live in food deserts.
So if you live in certain geographies rurally, if you live in certain inner cities, we have what is known as a food desert. And that is within urban areas of grocery store not within a mile, and in rural areas not within 10 miles.
Food deserts are urban or rural communities where people have limited access to healthy and affordable food. People who live in food deserts are often more likely to experience food insecurity because good food is harder to come by.
When I was growing up, there was a grocery store in town. That's no longer the case. And what happens is, with a high poverty population, they lack transportation. So the closest grocery store is roughly 5 miles away. So getting to it can be a challenge.
In 2022, approximately 17 million U.S. households experienced food insecurity. That's the equivalent of 4 U.S. states experiencing a lack of access to adequate food.
Food insecurity would be defined as not sure where your next meal is coming from. In this country, an awful lot of folks suffer from that. It is obviously income related. Certainly it is an equal opportunity issue relative to urban and rural. And it just has been something that we haven't solved, but we certainly continue to make a dent in. Because of this lack of food and lack of proper food, we get into a situation with these diet-related diseases. Who knew that diet-related diseases create more deaths, cause more deaths than alcohol, smoking, tobacco combined? So it is quite an issue in this country and something we really need to step up to.
But how can a nation that has so much have so many with so little? What can be done to assist those who experience food insecurity? And how can we turn these food deserts into food oases? The answers may lie at the intersection of technology and sustainability, a place where today's challenges can become solutions, supplying quality food through innovative ideas. Come along as we explore the future of agriculture and learn how we can grow a better tomorrow.
So some of the biggest problems that current agriculture methods are facing is really overextension. Our food demands are as high as they've ever been, and a lot of the farming practices that originally, came about, over 100 years ago, if not going back thousands of years ago, don't take into account the mechanization or the large-scale need for supply that we currently have.
By 2050, our population is expected to reach more than 9 billion people, which will require roughly double the amount of food currently being produced. This demand puts mounting pressure on food production.
So whereas 100 years ago the soil might have been very black and nutrient, now, it's red, it's brown, it's very clayey, there's not really as much in there, and tilling ends up sort of begetting tilling. Once you start doing that a lot and you started to get rid of a lot of the innate organic matter in the ground, then you kind of have to keep doing it because you've lost that soil structure.
Land degradation and the associated loss in soil productivity is often considered one of the biggest threats to our future food security, with the potential to result in landslides, floods, increased pollution, desertification, and a decline in global food production.
And then because of that degradation, people have to add a lot of fertilizers or other sorts of things. And because of how that works, there's never going to be the right amount. There's always going to be some excess. And then that excess then goes into the creeks, goes into the rivers, goes into the bays and the oceans, causing a lot of issues along the way. And that isn't just for drinking water. That's even as I want to go in the river and have a fun time tubing. You are affected directly by swimming in those sorts of waters.
Pesticides and other farm chemicals have long been associated with a variety of human health problems, including cancer. But many argue that use of these chemicals is the only way to sustain crop production and keep up with demand. And pesticides aren't the only issue that lingers after crops are harvested.
Then we learned that leafy greens, 95% are grown in Arizona and California. And so we started to do a little R&D. And we found out that farming has had one business model in this world for 50 years. We had no idea. And we figured out that 99% of all consumers in the USA don't have a clue where their food really comes from.
I asked Chad, how much does it cost to ship food from California to the Mid-Atlantic based on standard costs, drivers, trucks, produce, and it came back with a analysis, which was about $38 million a month, 8,000 trucks a month coming across this country to feed this area of the country. Now, all you got to do is say, don't grow it there, grow it here, and you just save the planet, climate change, 3 days of wasted time in a truck, so your waste goes up.
Shifting a system that has existed for so long presents a significant challenge, but technology has introduced some incredible opportunities for change.
So the other option is a controlled agricultural environment where you are in control of all of the factors that go in. So these would be hydroponic systems, aquaponics systems, things that are either within a greenhouse setting or within an otherwise controlled setting.
We are on the Steelton High Spire School District property, and on the grounds here we operate the Harrisburg University Aquaponics Research Greenhouse.
So hydroponics is soilless growing. Essentially it's using water that's been supplemented with fertilizer based upon what it is that you're trying to grow. Aquaponics is the combination of hydroponics and aquaculture. Aquaculture is fish rearing. or fish raising. And so aquaponics is now utilizing the nutrient-rich waste coming from the fish to be able to support that plant growth.
This greenhouse, located in the low-income food desert community of Steelton High Spire in central Pennsylvania, may provide an answer to many of the issues today's farms are facing.
So the plants get exactly the type of nutrients that they need, whether it's specific for lettuce or a tomato. We're able to pick exactly what that is. We also don't have to worry about soil erosion, soil degradation, or anything like that, which is always kind of a constant battle for outdoor soil-based farming.
Hydroponic and aquaponic systems provide high-quality food with improved yields for higher populations. They present a food production system without pollution or runoff, conserving resources with the ability to recycle water and have it go directly where it is needed. Fish waste further supplements the plants. Pesticides are typically not necessary, as issues can be mitigated within the walls of the greenhouse. Nearly everything can be regulated in the system, so waste is extremely low.
The entire realm of controlled environment agriculture opens up the possibility for season independent and location independent growing. So in an area like central Pennsylvania, where we have winters and we have regions that wouldn't be able to grow year round, we're now able to grow in an indoor space under controlled conditions so that we are able to provide food access year round.
But these systems are not without obstacles. Initial setup can be costly, and some crops do not adapt well to growth in hydroponic systems. Daily operational costs can add up as well, with environmental impact from electricity use in temperature control, lighting, and water pumping. Technicians must also closely regulate a variety of parameters to ensure the system's success.
One of the biggest challenges in growing in hydroponics and aquaponics would be all of the parts that are connected to one another. We have a lot of pumps in the system. We have a lot of valves that are controlling water rates and water flow. And so making sure that those are set up appropriately so that we have the right amount of exposure of that water, retention times within the space, so that the nutrients are subjected with a sufficient time for the plants to be able to uptake.
But what is most exciting about these systems are the potential opportunities for technology to simplify operations.
I stumbled across the student union greenhouse. I liked the idea that they were growing food. I was just a little bit interested in how they, manually do it. And I felt that the information that they needed to advance their research, their theories, their hypotheses was incomplete, and that became the essence of the problem. If you're a scientist trying to tweak the aquaponics system, yet you're relying on sparse data, it's kind of tough to do the what-ifs. And so I put together the idea that, if we were to automate the monitoring of different aspects of that system, that data could make itself available to the scientists, and including the student scientists, and that they could then make better decisions on what's happening in the student union aquaponics.
Automation presents a key to unlock the potential of hydroponic and aquaponic systems. With the right technology, these systems can be set up for automated testing, watering, and pumping. The more advanced the technology, the more independent the system can be.
So controlled environment agriculture just inherently uses a lot of different technology. That can be things like automation, sensors, and a whole variety of different things. Fortunately, there is a spectrum. So the ability to control is kind of up to the user. So we can start with a little bit more basic, kind of like a greenhouse, or a fully automated system where no human hands touch the produce at all.
But the goal of advanced manufacturing is collaboration. One of the pillars of Industry 4.0 is collaboration, working together. And so finding a way for students in the biology can work with students in automation, made sense from an education point of view. And so the scientists would provide the parameters for the information that's being processed, and the automation students would provide the ability to get it and massage it and then display it in a way. So the need to work together with somebody outside of their program, the reading and the specifications was a part of the learning. The ability to talk to a stranger was a part of the learning. Once they got comfortable with each other, the ability to talk to a professional like Josh was a part of the learning too.
So my role in the project was to act as support for the staff and students. And acting as support, I would help them specify the hardware used for the monitoring application, as well as provide examples on how to communicate the various sensors to other microcontrollers that were involved, as well as help them specify the hardware and how to map that and tie that into the software end.
This integration of science and technology has provided incredible opportunities at the Harrisburg University Research Greenhouse. Undergraduate students at Harrisburg University work in teams at the greenhouse to gain hands-on experience and develop skills to prepare them for success in the growing CEA industry, where they can utilize cutting-edge technology in potential learning breakthroughs.
So all Harrisburg University undergraduate students have to complete 2 semesters worth of research as well as an internship. The greenhouse has served as an environment for a lot of that authentic experiential learning opportunities, whether that be asking a question comparing the fertilization method of hydroponics to aquaponics to a hybrid system, or if it's beginning to look at the economics going into those types of controlled growing, or if it's looking at the integration of sensors into a bioreactor so that we're able to monitor in a timely manner and have that output. So it's a really neat living laboratory that our students are able to have a very immersive and authentic experience.
But the truly most valuable function of the greenhouse is the support it provides for the local community.
Working here makes you really realize of growing up here, it wasn't like it is now. Unfortunately, we're at a time now where there's a crossroads where people need help, people need services. Steelton High Spire School District is considered a food desert. When I was growing up, there was a grocery store in town. That's no longer the case. And what happens is, with a high poverty population, they lack transportation. So the closest grocery store is roughly 5 miles away. So getting to it can be a challenge. So finding ways to get healthy fruits and vegetables in the hands of our kids is 100% one of our goals.
So everything that we grow, from the lettuce, tomatoes, cucumbers, and even to the fish, go back into the community through community gardens programs and work with different nonprofits and food banks.
The Harrisburg University Greenhouse provides both fish and produce to downtown Daily Bread.
So I'm Chef Corey Lingenfelter. We are at Downtown Daily Bread in Harrisburg, Pennsylvania. We are a drop-in center. We are a kitchen. We are a one-stop community shop for the unhoused and those kind of seeking refuge from any type of walks of life, just, you know, down on their luck or maybe in between jobs, things like that. And then we also are a kitchen for those experiencing any type of food insecurity, hunger. So we serve breakfast and lunch within our food programs. We put a big emphasis on healthy foods, making sure we have our healthy fats, making sure good starches, good proteins. Produce was a huge thing for me. About 50% of the people we are serving don't get to regular doctor's appointments. They have high blood pressure. There are people dealing with diabetes. And so that is why it's so important for the overall nutrition, because we may be that only meal that they eat that day.
Downtown Daily Bread serves approximately 500 meals per day, which is only possible because of the university's greenhouse and donations from other area food banks. Offering fresh, healthy options at the center also educates the community, introducing them to foods and cooking techniques they might not be aware of.
Fresh vegetables, but by the time we get it from Cisco, it was not as high of quality. We would have to use it fast or else it would go bad. But those kind of concerns, we didn't have that problem once we made that connection with the hydroponics garden.
We serve 220 people per day here at Downtown Daily Bread. So monthly it breaks down averaging about 3,900 people. And as of 2023, we've done 75,000 meals. So that would look like about 50 to 60,000 people that have walked through the meal programs here.
It's kind of rooted in a feeling of giving back, okay? If I give back food, then it's a long-lasting gift. If I can sensitize students to realize that their skills and energy are useful to support themselves, their community, their society, then it is a long-lasting motivational gift.
But to make these systems catch on and spread and really grow to feed our food desert communities, we need to ask the important question: can hydroponic systems perform as a truly successful business model? Even more importantly, can they support our food desert communities and reduce food insecurity? Greenswell Growers is a large-scale indoor growing facility located outside of Richmond, Virginia. Greenswell Growers combines innovative technology and sustainable practices to bring delicious, safe, healthy greens to the community. Founded in 2017, this innovative hydroponic facility yields approximately 700,000 pounds of leafy greens per year, compared to the 32,000 pounds a traditional field would produce in the same footprint.
So it's a fully automated growing system from seed to your fridge, no human hands touch the product. We can grow the best product year-round. The same product you get in January will be the same product you get in July. So you get a 25x of what you would get out of traditional field growing, along with eliminating the freight coming from West Coast to East Coast.
Our shelf life is 18 to 21 days. California is 5 to 7, starting with when it goes in the truck. So in this world, the waste is 20 to 40%. There's no waste on our product. 18 to 21 days, we've all studied it. We could actually have a bag of leafy greens in our refrigerators for 30 days and it would taste the same as it does on day one.
So we grow in a hydroponic NFT system. It's a mobile gutter system. So what we're able to do is recreate basically the best conditions of traditional field growing. And that comes from the growing method that we use. That is a mixture of a soil-based peat moss system that allows those roots to kind of see the same things that they would see in the field. And we're able to get that fresh, crispy green leaf year-round.
So I like to group it into three major zones. There is the structure of the greenhouse and the technology that goes in there. There is the climate control and climate computer, and then there is the actual growing system. So in terms of the structure, we use a polycarbonate greenhouse that has ridge vents that allow us to choose if we're using inside air or outside air. All of that is controlled by our climate computer. Our climate computer says the temperature inside is too hot, it's cooler outside, let's pull in some outside air. We need to turn on lights, we need to turn on CO2, all of that kind of control. And then finally, the growing system is what actually moves the plants around, puts water on the plants, brings them to the harvest area, and ensures that crops are moving around without much need for human intervention.
But unlike traditional growing, the Greenswell Growers facility has very little impact on its surrounding environment. Water recirculation systems use 95% less water than traditional growing methods and essentially eliminate water runoff. Plants grow at a faster rate, and an automated harvesting system removes the risk of food contamination. With state-of-the-art indoor growing technology, the greens are grown and packaged completely hands-free, pesticide-free, and ready to eat.
What we did here is we found land. We found smart people that knew what they were doing to construct this structure here. Chuck found people that knew about Finland and how they grew food in Finland, so we knew what we had to buy from Finland, and we put it inside this structure. We put the roof on it, and then hooked it all up, turned the switch on, and started growing lettuce. Because lettuce turns out to be a major market. People eat a lot of lettuce, so that's what we picked, you know? Doesn't sound like a big deal, but it's a $400 million market in the Mid-Atlantic.
This business model presents quite a departure from traditional agriculture, where instead of plows churning up dusty soil in summer heat, at Greenswell Growers, plants flourish in an ideal, controlled, perfectly orchestrated environment year-round. 16 people run the facility, and everything else is automated. Amazing? Yes. But does it still leave room for today's farmers?
They have to have traditional agriculture. They got to grow things that we can't grow. If you're a farmer and you have land and you see a facility like this and your kids come in and go, wow, this is something I can do. It's got the next, it's got more meat on the bone, so to speak, because it's got technology, it's got growing, it's got logistics.
Traditional agriculture is very advanced. Farmers are some of the smartest people that we have in this country, and every year yields improve in the field, and so we're trying to emulate that same thing. We basically take the best technologies from field farming and try to apply those same concepts in a more controlled manner here.
So controlled environment agriculture will never be and shouldn't be a replacement for traditional agriculture. They both serve very important purposes, and food insecurity will be better met when both of them are further researched, further optimized, and become more efficient. And that's really what we're trying to do is figure out when we should use controlled environment agriculture, when it makes sense, when it doesn't, and the more efficient that it can become, the better it can work to alleviate food security in the instances that it's the right choice.
So between the combination of the increasing global population, as well as decreased arable or farmable land, there's a need for innovative ways that we're able to provide food access to populations, especially in urban food deserts where there's a lack of transportation or access to healthy food. The realm of controlled environment agriculture provides a way that we're able to give culturally relevant, diverse, healthy crops to those individuals on a very consistent basis.
With controlled environment agriculture, we're able to utilize a lot smaller of a growing space, so we're able to put it inside of a city. Whether that's a warehouse, an abandoned building, a vacant lot, or just a business that somebody has built up, we're able to do it all indoors and in a lot less space. So we're able to cut down on those food miles and grow right where there's a large mass of people, which means easier access to fresh and healthy food.
Nothing will replace traditional farming and our amber waves of grain, but hydroponics can fit into places that our traditional food systems cannot reach. With scientific research backed by cutting-edge technology, scalable hydroponic and aquaponic systems present an incredible solution to answer current food insecurity needs. Is it the end for food insecurity? Not quite. But it is a path that we can start on to grow a better tomorrow.